Imagine waking up tomorrow morning. The sun still rises, birds are still singing, and everything feels completely normal. People are driving to work, kids are heading to school, and life goes on just like any other day. But somewhere out there, in space, deep beneath Earth's surface, or even in the fabric of the universe itself, a chain of events has already begun that could bring everything to an end. It might sound like something straight out of a science fiction movie, but the truth is that scientists have spent decades studying the many ways our planet could one day become uninhabitable. Some of these threats are incredibly unlikely, while others are slowly unfolding right now. A few won't happen for billions of years, but every one of them is grounded in real scientific theories and observations. So today, we're counting down every major way Earth could end, starting with the most familiar and ending with one of the strangest possibilities modern physics has ever imagined. Asteroid impact. When most people think about the end of the world, they picture a massive asteroid hurtling toward Earth. It's dramatic, terrifying, and surprisingly realistic because it's already happened once before. About 66 million years ago, a giant asteroid roughly 10 kilometers across slammed into what is now Mexico's Yucatan Peninsula, called the Chicxulub crater. The impact released more energy than billions of nuclear bombs, sending enormous shockwaves across the planet. Wildfires spread for thousands of kilometers, earthquakes shook the Earth's crust, and towering tsunamis raced across entire oceans. Dust and debris filled the atmosphere, blocking sunlight for months and causing global temperatures to drop. Plants died, food chains collapsed, and nearly 3/4 of all living species, including the dinosaurs, disappeared forever. Global fungal pandemic. When people imagine a global pandemic, they usually think of viruses or bacteria. But fungi may be an even more underestimated threat. Unlike bacteria, fungi are remarkably difficult to treat because their cells are surprisingly similar to our own. That means medicines that kill fungi can also damage human cells, making treatment much more complicated. It's like trying to remove weeds from a garden when the weeds look almost identical to the flowers. As Earth's climate warms, researchers worry that more fungal species could adapt to higher temperatures, making it easier for them to survive inside the human body. We've already seen dangerous fungi like Candida auris spread across hospitals around the world, where it can be difficult to eliminate once it takes hold. Scientists don't believe a fungal apocalypse is around the corner, but because fungi are less understood than viruses, they're becoming an increasingly important area of medical research. Ancient pathogens. Some threats don't come from space at all. They come from the past. As global temperatures rise, glaciers and permafrost that have remained frozen for tens of thousands of years are beginning to melt. Hidden within that ancient ice are bacteria, viruses, and microorganisms that haven't encountered modern life since the Ice Age. Think of the frozen ground as nature's freezer. For thousands of years, it has locked away organisms that disappeared long before human civilization even existed. Scientists have already revived microorganisms that remained frozen for over 40,000 years. Most are harmless, but the concern is what else may still be trapped beneath the ice. If an ancient pathogen emerged that modern immune systems had never encountered before, it could spread before doctors even understood what they were dealing with. We already know how quickly diseases can travel around the world thanks to airplanes and global trade. An unfamiliar pathogen could make containing an outbreak even more difficult. Thankfully, there's no evidence that a civilization-ending ice virus is waiting to emerge. But researchers continue studying these frozen microbes to understand what risks they may pose. Magnetar flares. These are the collapsed cores of massive stars, packed into a sphere only about 20 kilometers across. That's roughly the size of a city, yet they can contain more mass than our sun. Imagine squeezing something hundreds of thousands of times bigger than Earth into something small enough to drive across in less than half an hour. The result is one of the most extreme objects in the universe. Despite their small size, magnetars possess the strongest magnetic fields ever discovered, trillions of times stronger than Earth's. If a magnetar released a powerful flare close enough to our planet, the consequences could be devastating. Satellites would fail almost instantly, communication networks could collapse, and high-energy radiation would slam into Earth's atmosphere. Even our power grids could be affected if the burst were intense enough. Fortunately, every known magnetar is thousands of light-years away, far enough that none currently pose a serious threat. But our galaxy contains hundreds of billions of stars, and astronomers are still discovering new objects every year. It's entirely possible that somewhere in the darkness, there's a magnetar we haven't found yet. Interstellar molecular cloud. Our solar system isn't standing still. As it orbits the center of the Milky Way, it travels through enormous regions filled with gas and dust known as interstellar molecular clouds. These clouds can stretch for hundreds of light years and contain enough material to eventually form entirely new stars. Imagine driving through a thick fog. You can still move forward, but visibility drops, and everything around you changes. In a similar way, our solar system could someday pass through one of these dense clouds. If that happened, the cloud could interfere with the sun's protective magnetic bubble, allowing more cosmic radiation to reach Earth. Some scientists even think encounters like these may have influenced Earth's climate millions of years ago, although the evidence is still being studied. Even the seemingly empty space between stars isn't truly empty. It's constantly changing, and our solar system is moving through it every second. Earth gets ejected from the solar system. Earth's orbit feels permanent, but it's held together by gravity, and gravity can be disturbed. Imagine swinging a ball tied to a string. As long as the string stays tight, the ball keeps circling you. But if someone suddenly cuts the string, the ball flies off into the distance. Earth behaves in a similar way as it travels around the sun. If a rogue star or another massive object passed close enough to our solar system, its gravity could disturb the planet's orbits. In an extreme scenario, Earth could be flung completely out of the solar system, becoming a lonely planet drifting through the darkness between stars. Without the sun's warmth, temperatures would fall rapidly. Oceans would freeze from the surface downward, plants would die without sunlight, and most life would disappear. Rogue star capturing Earth. Being thrown into deep space isn't the only possibility. Imagine another star passing close enough to steal Earth from our sun. Instead of drifting through the darkness forever, our planet would begin orbiting a completely different star. Whether that would be good or bad depends entirely on our new sun. If it were smaller, Earth could freeze into a giant snowball. If it were larger, the oceans might boil away. Or we could end up on an unstable orbit that swings from unbearable heat to extreme cold every year. It sounds like science fiction, but astronomers have observed stars stealing planets from one another inside crowded star clusters. It's incredibly unlikely to happen here, but the laws of gravity allow it. Primordial black hole. Not all black holes form from dying stars. Some theories suggest tiny black holes may have formed less than a second after the Big Bang. These hypothetical objects are known as primordial black holes, and unlike their enormous cousins, some could be incredibly small while still possessing tremendous mass. Think of dropping a bullet through an apple. The bullet doesn't eat the entire apple. It simply punches straight through it. A primordial black hole passing through Earth would behave in a similar way, except the bullet would be an object with gravity so intense that it could disturb the planet's interior as it passed. Depending on its size, it could trigger earthquakes, volcanic activity, or leave Earth permanently unstable. So far, however, scientists have never found convincing evidence that primordial black holes actually exist. Strangelets. Now we enter one of the strangest ideas in modern physics. Before we get to it, I want you to subscribe and leave a like. It'll help the channel out, so yeah, thanks. Everything around us is made from ordinary matter, but some physicists have proposed the existence of an exotic form known as strange matter. If a tiny piece of strange matter, a strangelet, were stable, it might convert ordinary matter into more strange matter simply by touching it. Imagine one domino knocking over the next, then another, and another. That's the frightening idea behind strangelets. One microscopic particle could begin a chain reaction that slowly converts everything it touches into the same exotic material. Fortunately, this idea remains highly speculative. decades of particle physics experiments have produced no evidence that dangerous strangelets can form, and most physicists consider this scenario extraordinarily unlikely. Vacuum decay. Out of every scenario on this list, this may be the most unsettling, not because it's the most likely, but because it would happen without any warning at all. Some physicists believe the universe may exist in what's called a false vacuum. Think of it like a ball resting in a small valley instead of the deepest valley nearby. It looks perfectly stable, but one tiny push could send it rolling into a lower position. If that happens somewhere in the universe, a bubble of this new vacuum would begin expanding outward at the speed of light. Inside that bubble, the fundamental laws of physics could be completely different. Atoms might no longer exist. Chemistry could stop working. Stars, planets, and life itself would simply cease to function. Because nothing travels faster than light, no telescope could ever detect it before it arrived. There would be no warning, no alarms, no countdown. One moment you'd be watching this video, and the next, the universe itself would obey entirely different rules. That's what makes vacuum decay one of the most chilling ideas ever proposed in theoretical physics. So, that's every major way Earth could end. At least some of it. If you enjoyed exploring the strange side of science, don't forget to like, subscribe, and let me know in the comments. Which ending do you think is the most terrifying? Thanks for watching, stay curious, and I'll see you in the next cup of curiosity.